right. Another thing I was thinking of is just just in terms of the sense of perspective that you get when you think about things on an interstellar scale. I think that's another thing that might be able to have a certain power to stimulate the imagination once you realize just how much bigger our environment is than just our planet, which itself can be very big. Depending on depending on a lot of things. Of course, as civilization has progressed, as we were talking about earlier, we've developed a lot of different means of traveling. So to that extent, our world has gotten a little smaller, but there's always that aspect of perspective when you take into consideration the ever widening reach of civilization as we're attempting maybe to try to find other habitable planets or something in the far future, of course. Let's see. Oh, and all right. So apart from that, another thing that kind of interested in me, concepts that are related to deep space travel is sometimes when you're talking about black holes, you talk about the interrelatedness of time and space as it relates to gravity, and that was something that came across when I was doing some research on black holes. So that was something that I was thinking maybe maybe there might be some sort of propulsion maybe that used the gravitational field of a black hole, maybe that to kind of tap into that and harness it as a means of propulsion, or maybe some sort of gravitational gravity,
like a slingshot.
Exactly. I'm sure maybe you guys have seen it also. There's sometimes there'll be some sort of maneuver that people will do in their spaceship that revolves using the gravitational pull of a black hole to to kind of accelerate themselves or like slingshots themselves around it. So that's another thing that's interesting. And when you think about that, you kind of think about all the different forces there are in the universe sometimes, and the various ways that that they could affect us and and affect the way we interact with our environment. Let's see. Did you have anything else to say about that?
Well, one particular thing too, as far as another form I actually hadn't really looked at, but we'll also get back into, say, the wormhole theory. One was just kind of vague, which was the evolution of living beings, and then cryogenically sort of freezing them, and then unfreezing them, and then quickly I guess you would call it re-evolution. But that may or may not work because of cellular consistency, any kind of mutations or anything like that. You might start out with Bob. Bob is, somehow chemically or some form de-evolved to maybe Paramecium or something to that effect, or amoeba, basically, probably is closer to what we may have started if you're kind of a follower of evolution. And then if you were to send us back through the scale, back through amoeba to sort of sponges, jellies, later anything from a sea cucumber on up, worm-like creatures, fish, amphibian, reptile, lower mammals, of course, primates and us. If you were to do that, say, within maybe over some years, going through space, that may or may not, you might not end up with Bob. You might end up with I don't know, just a slight, from Bob to Bobby might be not the same person, not the same, you might have somebody who can't even speak or something crazy like that. So that's the idea that people may be able to do, maybe with some form of lower creatures, something maybe people, like I said, this is speculative science, so it's not really something that you can actually so much do, but we deal with certain forms of plausible hypotheses. Getting back to the black holes, I'm a real big fan of the wormhole theory, which is basically was presented by greats such as Einstein, everybody knows, where you have two essentially black holes that either one could be, in other words, a belief that that space and time are, of course, one, which is time space or specifically space time, and you flip it over on itself. So in other words, you can't have one without the other. Space and time are somehow cohesive. I'm not actually a fan of that, because I still do see, I mean, if I walk down the street, you know, time is not slower. It takes longer than driving a car, but just because I get in a car doesn't mean I'm traveling through time. I'm just have a quicker means of travel. But anyway, basically with the wormhole theory, you have a black hole on one side and a black hole on the other, essentially a white hole, which is the opposite end of the black hole. And instead of sucking out all kinds of material, it spews material on the other side, which we can sometimes, scientists claim we can somewhat witness. But like I said, we'll get further in that discussion. But with the wormhole, basically you have two black holes that are touching each other. Now it could be out of parallel universes, or it could be within the same universe or even same galaxy, and it's basically just being able to go from one side to the other. It was somewhat used in a synthetic way in one of our classic movies, Stargate. Everybody loves Stargate, the movie and the series, where you're able to create this sort of wormhole, travel through time a lot faster, time space, of course, faster, and end up in another, planet, another galaxy, however. So that's one major form of travel. Now, the biggest thing is how to do that. I would think that it would be easier to control smaller synthetic forms of black holes, which scientists have tried to do as far as colliding basically matter and antimatter, and then trying to show that there is actually a missing amount of matter as far as electrons or anything like that. And that's somewhat of an experiment that's taking place. We'll probably keep you posted. As much as we know, we can definitely share with you. That's something that they're planning to do. I believe it's in Silicon Valley, but I'm not sure. I'll have to look into that. But one of the major things is that to create a synthetic wormhole, essentially what you would have to do is, there's another theory of dark matter, and basically there's no such thing as a vacuum in space. There's always something filling space up. You might have less matter as what we would consider or understand as matter, but there's no such thing as just total nothing. So there literally is somewhat of a fabric of the universe. So if you could essentially rip that apart, whether it be through some form of nuclear explosion, high beam laser, high energy, to scatter the matter, then what you would have essentially, if you could do that, is the means to actually kind of punch a hole and be able to travel through. Now, by creating the wormhole at the end, the furthest focal point would be a form of singularity, where time-space would be out of whack. It could be a number of things. You get ripped apart, you get crushed. It's kind of the realm of the unknown. But there was a force to slingshot you through there somehow. Somewhat what Dana was talking about, where even on not so much the outside, but maybe actually inside of the actual wormhole, in this case black hole, maybe there's a way to kind of like, you flush the toilet, you see how much energy is going around there, so maybe there's a way to kind of slingshot through there and go through that point of singularity and come out on the other side, which of course you'd be forced out, like when you build up energy on a rubber band, pull it back, snap it, you essentially have more kinetic energy built up than actually is released, but of course the band snaps further. So in that sense, if you had, say, a ship at the end of that band, you might pull back only so far, but once you let go, you're going to go out there. So that's one major theory that a lot of scientists have thought about as far as going through wormholes. Let's see if I have any other information to share on that. Let's see here. And once again, thank you, Charles, out of Sacramento. Synthetic black holes. And I think that's it for the black hole, so we'll go back definitely to see what other ideas Dana has for us on that.